Are you someone who's struggling with indices and tired of just memorizing the concepts instead of really understanding them? Don't worry, you're not alone. Today we're going to tackle all the rules that you need to know for indices, and then we're also going to do some examples so we can clear that doubt away. So stay tuned. And don't worry about writing the notes down. I'm going to leave the link to these notes in the description so you can access them there. Now, what is indices basically? Indices is the plural of index, okay? Indices is the plural of index. Index means power. Indices means powers. So it's basically the study of knowing the powers. Now, let's see the first rule that we have. First rule is, let's say a power, let's say m, multiplied by a power n is equal to a m plus n. Now you may ask, what's a, what's m, what's n? Well, what are you doing? Okay, don't worry. A is any number, okay? So for example, let's take an example here. For example, I have, let's say, 4 power 3 multiplied by 4 power 6. Now, 4 is a, okay? So that means if we have one number here, another number here, and they're the same number and they have different powers, what will we do? We can simply write the number that we had, okay, 4, then m plus n, that means 3 plus 6, m and n are powers. Then 4 equals 4 power 9. That's the rule. Let's do one more example. Let's say I have 6 power 9 multiplied by 6 power 11. You will have 6, the same number, then the 2 powers added. Okay, 9 plus 11. 9 plus 11 gives me 20. That's my rule. Now, what's the key rule that we need to know here? Okay, so we know the actual rule by its words as well. Now, if we have two numbers that are same, being multiplied, let me fix this. And their powers are different. Then we write the number as 1, or write the number one time, basically. Write the number one time and add the powers. Now remember, what are the keywords here? Let me highlight them as well so we don't miss them out. Where's my black pen? Okay, where is it? Let's see here. Okay, if we have two numbers that are same being multiplied and their powers are different, okay, and the powers are different, then we write the number one time and add the power. So these are the three conditions, okay? That was the first one. Second, it's gonna be about the same, just with a different concept, okay? We had a power m times a power n equals a m plus n. Now what if I have division? I had multiplication above. What if I have a power m divided by a power n equals, that would be a power m minus n. So the key is, if you have multiplication, you add them with these conditions, obviously, same numbers multiplying in different powers. And this is the exact opposite, but the same rules apply, okay? If we have two numbers that are same being divided and their powers are different, then we write the number one time and subtract the power. So the key difference is subtracting and dividing, okay? Let's quickly do one example to understand this. Let's say I have, let's write it here. Let's say I have 6 power 9 divided by 6 power 4. What will that give me? I'll write 6 one time, okay? Then I will write m, that is 9, minus 4. Simply I get 6 power 5, and I simplify it. So what we're gonna do, we're gonna tweak this. Let's first copy this here. Where's my lasso? Okay. Now remember, exact same rule. Only thing that changes is that we have to take the division and we have to take the other part. Let's mark it here. Okay, got it, and here. Okay, now two things we want to change. One thing, it's dividing. Second thing, subtracting powers. Okay, where's my pen? Here we have it. Divided and times, so one time, and subtract the powers. Okay, and same thing again, we're going to highlight our keywords, that is division here, and we subtract it. Let's also take this here so we know what we have to do. That's the second one done. Next up, we have the next rule. Now this is going to be a bit different. For example, the last one, we did am times a power n equals a power m plus n. Now it's going to be a bit opposite. Before, we had the same number, different powers. Now we're going to have the different numbers, but same power. So for example, I have a power m and multiplied by b power m. What do I do now? Simple trick is, take these common, so a times b, and then just put the power on top, like that. Okay, let's see an example. For example, I have 6 power 9 multiplied by 4 power 9. What do? 6 and 4 come inside, like this. 9, 9. We don't write 9 plus 9, okay? We just write 9 one time. Let's see one more example. Let's say if I have 3 power 2 multiplied by 6 power 2. What do? 3 times 2, the two numbers that are opposite, the different, then write the power as 1. That's the rule. So this one's going to be, let's write that down here. If we have same power and different numbers being multiplied, then put numbers in bracket and put whole power outside bracket. Outside bracket. Okay. Now the next one is, yeah, you guessed it, we're going to take the fourth one first here. It's going to be the opposite rule. We have, let's say, a power m again. Now division in the middle, b power m equals, you already know, a minus b whole power m. Let's take one example and then move on. Let's say I have 11 power 4 divided by 11 power 2. What do? Oh, no, not this. I mixed it up with the previous one. 11 power 4, and we have, where's my pen? Here. Then divided by 6 power 4. What do we have? 11 minus 6. Okay, 11 minus 6. Or sorry, divided by 6. Then times the whole power. So let's recap that again. If we have the two powers that are same and we have different numbers dividing, we don't write minus in the end. We write division sign and then we put the whole bracket, the whole power above them. Okay, so the rule is going to be, let's first take it, where's my lasso? Exact same thing here. Okay, copy it, copy, then paste here. And here we got it now. Okay, let's also highlight the keywords. So if you have same number different powers being multiplied, nope, divided. Okay, and put the same number bracket and put whole and power. Okay, exact same thing. Just the thing that's going to change here is our division sign is being divided. We also highlight that here. So dividing here and multiplying that here. Now this next one, actually these two next ones are not like basic rules, but they're just the opposite of it. What does that mean? Okay, let me explain it here. There's my pen. The fifth rule is, you know, we discussed above that a power m times b power m is a times b whole power m. It's the same thing in reverse. That means if I can make this into this, I can make this back into this. That means the rule will be a times b whole power m can be written as a power m times b power m. Okay, and the same thing. So if I have the sixth one as well, it's going to be the same one for division. If I have a, oh sorry, this is division over here, just noticed. A divided by b power m is equal to a power m divided by b power m. So these two are not like basic like rules per se, but still you have to know them. Let's mark that here. These two are not actual rules, but a reverse of above two rules. Okay, now rule number 7 is going to be a bit different, but don't worry, we just have a few more rules left, then we can finish this. 7 is going to be if I have, let's say, a inside a bracket and I have the power m, and outside the bracket I have another power n. What does that become? That's a m plus n? No. Minus n? No. Multiplied by n. If I have something like this, whenever I have a number and it has a power and it's in a bracket and outside the bracket I have another power, I'm gonna multiply the powers. For example, give me an example, sir. Okay, no worries. Let's say I have let's write it here. One second. Example: 6 power 3 whole power 9. What do? Simply 6 3 times 9, that makes it 6 power 27. Okay, so that's the basic rule. Let's write that down as well. Where are our notes? If a number with power is in brackets and there is an outer power, then we multiply both powers. Keyword is multiply. Is in brackets, okay, and there is an outer power, okay, so we multiply over here. Now the next rule is a bit easy to remember, that if you have any number to the power of 1, any number to the power of 1, it's going to equal itself. Meaning, for example, 6 power 1 is 6. 1122 power 1 is 1122. Or 60 power 1 is 60. So anything to the power of 1 is itself. Let's write that down as well. Anything to the power 1, power of 1. Let me fix this so we don't see it. Here. Anything to the power of 1. Man, come on. And the power of 1 is itself. Okay, now let's move on to the next one. Next rule is that if I have anything to the power of 0, that's one. Then you never make sure to not confuse these two. This one and number 9 that we're going to do. Anything to the power of 0. Let's say a power 0 is 1. For example, minus 5 power 0 is 1. 1,000,000 power 0 is 1. So anything to the power of 1 is itself. So anything to the power of 0 is 1. Anything or 0 is 1. Okay, then okay, next rule we have that if 1 has power of anything, so 1 power a is 1. Now we have 3 different rules that might involve 1. Okay, I'm going to first explain this one, then I can go back to them. 1 power anything is 1. So for example, 1 power 100 is 1. Another example, 1 power 238, for example, is 1. So anything, let's write it right here. If 1 if 1 has any power, it will still be 1. Still be 1. Now, what's the difference between them? Let's see. Where is my hand? Okay. A power 1 is A, meaning anything to the power of 1 is itself. Okay. Second rule, anything to the power of 0 is 1. That's the second rule. And the last is 1 power anything is 1. So never mix up these. Some people may mix up these 3 rules and get the wrong answer. But if you just remember these rules that I wrote on the side, you can use these, and yeah, that's going to be good for you. Now, let's look at the next one. We just have 2 or 3 more remaining, I think. Okay. Next one is if we have fractional powers. We've done 1 by 1. Now we have fractional powers. What does that mean? That means, let's say if I have a power, let me first write this down. For example, this is better to understand with an example. Let's say if I have 6 over 9 whole power cube. What does that mean? That basically means 6 has power 3 and 9 has power 3. This is not just for 6, this is for 6 and 9. Another example? Okay, no worries. For example, let's take a mixed fraction. Let's say 1 3 by 8 has whole power 6. Okay, what do? First, you make this into an improper fraction. How do you do that? 8 times 1, then the answer plus 3. Okay, that's going to give you 8 times 1, 8, plus 3, 11. So 11 over 8 has power 6. Then you open it up, 11 power 6, 8 power 6, and you get your end answer. So that's the 11th rule. Then, let's see the second one, sorry, the 12th one. Now, we have now the last, I think maybe 2 or 3 rules that we're going to have to do. These may be a bit tricky, but still, they're not too tricky. Next is that if I have, and these are better to understand with examples. For example, if I have 7 power negative 3. Now I have a negative power. How do I make this negative power into a positive power? To make it, you have to know one thing, and I'm going to explain this again. Is there any difference between 7 power negative 3 or 7 power negative 3 divided by 1? There is no difference. Okay, but if there's no difference, so why do you write it? I'll explain why I write it. First, let's make this over here. Let's write this here. That means 7 power negative 3 over 1 can be. Now, to make the power positive, actually let me write it here so I can write the rule as well on the side. Okay. That would mean 7 power negative 3 divided by 1. If I want to make the power positive, I will flip the entire equation. Meaning 1 comes up and this comes down. So it's not negative, this is plus. Sorry, let me erase this so don't get confused. Okay. Now, that means 1 comes up, 7 goes down. Now the power becomes positive. Okay, let's do one more example to understand this. Let's say I have 8 power negative 6. I say, okay, is there any difference if I write 8 power negative 6 or 8 power negative 6 divided by 1? No difference. Okay, let me take this. Then, to make the power positive, we will flip the equation, or we may call reciprocal. That 1 will come up and 8 power negative 6 will come down. That's going to give you 1 over 8 power 6. That's the rule. Now let me first write it down. To make a negative power positive, you will flip the fraction. You'll flip the fraction. Okay, that's what you have to do. Now that's what we have to do. Now the last rule that we have is the final rule, that what is the meaning of a square root? Like, we know that square root of 4 is 2, but what does this actually mean? What is the meaning? How do we know what's the square root, or what's the cube root basically? The square root basically means power 1 by 2. So if I have 4, that means 4 power 1 by 2. If I have, let me write it here, 4 cube root, That means 4 power 1 by 3. Okay, so now you might say, okay sir, but what if I don't, if I have a power inside? For example, if I have, let's say 4 power 3 whole power 6, now what do I do, sir? Okay, let me explain. Write the 4. This number, this power comes above. This power comes below. So you have 4 power 3 by 6. If you simplify it, that is 4 power 1 by 2. That means under root of 4. That means 2. So remember, the power that is inside will come on the top as a numerator, and the power that's outside the cube root will come, the root will come down, meaning this is, it's a denominator. That's what you have to know. And remember, never will the questioner ask you about like these simple techniques. They may, but most chances they won't. You will be given questions where you have to use the concepts that I just taught you in those questions during the past papers. So you're not going to be asked like you could say direct questions about indices, but you're going to have to use things from indices to solve questions of algebra. So yeah, that's it. We have done all the rules. Now, one final thing. This was for algebraic, like this is the beginning of algebra. The indices is the beginning of algebra. What if algebra comes in other places as well? For example, algebraic fractions. Okay, I made a video on that as well. You're going to have that video come in front of you. If you want to learn that, you can go to watch it. And I've explained in detail how to solve algebraic fractions over there. And yeah, that's going to be for today. If there's any specific topic you want me to do, then leave a comment and I'll hopefully make a video on that as well. Thank you.